Hello, today we are going to learn indefinite integration. This is a small section in Calc 2. The reason for that is Calc 2 is focused on integration, generally integration, definite integration, indefinite integration, and several types of integration. Since we learn integration throughout this course, that is Calc 2, we don't spend much time learning indefinite integration in this section because it's kind of redundancy. First of all, the indefinite integration is the integration that does not involve bounds. Give me a second. View that. The integration that doesn't involve bounds. All right. Since you learn definite integration, you know that definite integration involves bounds. Okay. If you just recall your memory, definite integration is something like this that you have already learned in previous sections. There's a curve, and if you want to get the derivative of get the integration from a to b, you write integration of this function, which is f of x from a to b. Okay, this is called definite integration. All right, it's a recall. All right, in indefinite integration, you don't have these bounds. Okay, this does not involve bounds. Now you don't have these bounds. You don't have these bounds in indefinite integration. All right. Let me write down a small definition for that. Let uppercase f of x is the derivative of the function f of x, sorry, then indefinite integration is defined as, let me say, indefinite integration of f indefinite integration of f is defined as this. Which is simple f of x plus a constant. All right. You always have to put this constant where c is a constant. All right. You always have to put this constant. I explained this early in this course. All right. Now we directly move to examples, because this section doesn't have any theorem or any definition other than this definition. So directly move to examples. Let's move to example number 1. We have to integrate x to the power 4 minus 2 secant square x dx. Okay, here also you have to use the properties of integration. As you remember, in one of the early sections, I gave you a set of properties of integration. So you have to use those properties of integration. And also in the early section, I gave you all the formulas that you could use when you are working on integration. So all those formulas are also required here. All right. So here the first property explains you can split this into two problems like this. First you write 10 x to the power 4 dx and minus, then you write 2 secant square x dx. Okay, that's a property I gave you early. Now another property in that list says you can get the constants out. Okay, then you write secant square x. All right, now you have to use formulas here. There are two formulas you could use. The first formula that you could use is the power law for integration. That is something like this. If you have to integrate x to the power n, then you could write this as x n plus 1 or n plus 1. All right, so that's the first formula that you have to use here. And the next formula is integration of secant square x. Integration of secant square x is actually tan x. You have to use both of these formulas. In the first case, you have 10 x to the power 4. The power is 4. If you had n, you have to put n plus 1 here. Now you have 4. You write x 4 plus 1 overflow plus 1, and then minus 2. For secant square you could put tan x. All right, now I put one constant. Actually you will get two constants, one constant for that part and another constant for this part. Then you can sum them up. You can sum these two constants and just produce one constant. So that constant is c here. I put only one constant to represent the constant coming out from here and constant coming out from there. All right, now you have to simplify this. So this is 10 divided by 5 x to the power 5 minus 2 tan x plus c. 10 over 5 is 2. So you just put 2 here. All right, so that is the solution. Example number 1, and then move to example number 2. In example number 2, we are going to integrate x to the power 10 plus 10 to the power x dx. All right. The same scenario here. There are two functions. You have to split the integral into both functions. The first function says x to the power 10. Then you have to integrate that. The second function says 10 to the power x. You have to integrate that. All right. Here you have 10, x to the power 10. For that you could use this power law for integration. Here you write, here you write n is 10, so you write x 10 plus 1 over 10 plus 1 and plus, there's a formula. I don't know whether you know how to integrate that. This is not the power law. Okay, so here you can't use this. Let me mark it. What I want to say is you can't use that. Okay, no, you can't, because that is not the power law. You can't use that formula. It is not the power law. There's a different formula for this case. Okay, here the power is a variable actually. Here the power is a variable. In order to use the power law, so this should be a constant. Okay, so that should be a constant and this should be a variable. All right, in this case the power is a variable, so you can't use the power law. For that you could use a different formula. Now I'm going to put that formula. I don't know whether you know this. Probably you might know this because you have done differentiation. If you don't know this, that's all right, because you are learning that right now. Okay, let's say you are integrating b to the power x dx. Here b is a constant. Here b is a constant. The integration of that one should be b to the power x over ln b. Keep this formula in mind. This is also required for your exams. Okay, if you don't know this formula, keep this. Make sure you can remember this. Okay, if you have integration b to the power x dx, and then the solution for that is b to the power x over ln b. Now I'm going to use that formula. Here b is like 10, so you write 10 to the power x over ln 10, and then you put one constant. You put one constant for both of the constant. Why I say both of the constant? You have to get one constant out of that, another constant out of that. So you add them up and then put one constant instead. Okay, the simplification of that one is x to the power 11 over 11 plus 10 to the power x over ln 10 plus c. Okay, so that's the second example. Now I'm moving to the third example. The third example is integration 2x to the power 3 minus 6x plus 3 over x square plus 1 dx. I'm sorry. Alright, so this is the next example. Here you have three functions, so you have to split this integration into each function. First to write integration 2x to the power 3 dx minus integration 6x dx plus integration 3 over x square plus 1 dx. All right, now check whether you have constant. You have number 2 as constant, so you take 2 out, you write x to the power 3 dx. Minus 6 is a constant, you take 6 and then you write x times dx. Then you take 3 out and here you write 1 over x square plus 1 dx. All right, now we're going to integrate them separately. X to the power 3, which is a power law case. Okay, so you have to use the power law. The power law is given early. It is right here. So you are going to use that power law. Right, go down. Here you write 2 times x to the power 3 plus 1 over 3 plus 1. Then minus 6. X to the power 1 plus 1. 1 plus 1 plus 3 times the integration of that one. Or what's the integration of that one? I don't know whether you can remember. So I gave you the formula for this one early. The formula is actually this. Integration 1 over x square plus 1 is actually arctan. Okay, arctan x. You could use that formula here. Then 3 times arctan x, and then you have to put a constant. I put one constant, but actually you have 3 constants. One out from here, one out from there, one out from there. I add all the constants and then put one constant instead of putting 3 constants. All right. Then I'm going to simplify this. This is 2 over 4 x to the power 4 minus 6 over 2 x to the power 2 minus 3 tan inverse x plus c. This is x to the power 4 over 2 minus 3 x to the power 2 3 tan minus x plus c. All right, so this is the solution for this problem. We are moving to the next problem. The next problem is that is problem number 4. That is integration 2 plus tan square theta d theta. All right. All right. Now again, there are 2 functions. You have to split the integral. First, the first integral is different integration of 2, and the next integral is tan square theta. All right. The integration of first one is easy. You can take 2 out, and then it is the integration of 1, and here tan square theta. Now you have to check whether there's a function for that or a formula for that. Do you have a formula for the integration of tan square theta? You don't. You don't have any formula for that. All right. Because of that reason, the second step is try to find whether there's a trigonometric identity that transforms this one into a another trigonometric function that you can integrate. All right, so this you can't integrate this itself. The step one is to check whether you can integrate this, but you can't integrate that. Because of that reason, you are thinking about an identity, trigonometric identity, that transforms this into a trigonometric function that you can integrate. All right, so that's a nice trigonometric identity. That identity is secant square theta is 1 plus tan square theta. All right, since you need tan square theta, you write tan square theta equals secant square theta minus 1. Okay, so you could use that identity. Now I'm writing integration secant square theta minus 1 d theta. All right, so then you write 2 times 1 d theta and then plus. Here there are two functions, so you are going to split that. Secant square theta d theta minus 1 d theta. All right, and the integration of this one is just 1, that is x to the power 0. This equals x to the power 0. Okay, x to the power, for x to the power 0 you could use this power law. You could use this power law because it's x to the power 0. X to some power. 0 is a power here, valid power. Okay, so you write this to be 2 times x to the power 0 plus 1, 0 plus 1, and secant square theta is, see, it is tan theta. All right, so it is tan theta. You could get that. Give me a second. Yes, you could use that here. So this should be tan theta minus, again x is x to the, 1 is x to the power 0. So you write x to the power 0 plus 1, 0 plus 1, and you put one constant for all the constants. All right, then this is 2 this is 2x plus, I'm sorry, I made a mistake actually. The variable here is not x, the variable here is theta. All right, so I put x here, which is wrong. I put x in these two places. That's wrong. The variable is theta. All right, so let me correct them. So this is not x, that is not x. They should be theta. All right, so let me correct that. This should be 2 theta plus tan theta minus theta plus c. This 2 tan theta can be simplified with that theta. So it is theta plus tan theta plus c. Okay, so that is the solution. Here we discuss 4 examples. All the examples are more likely similar. I mean, we don't do any fancy things here. We just get the given problem and then just integrate by using indefinite integration principles. In indefinite integration, what happened is you get this constant c. Okay, you get that constant c. All right, that's different than the definite integration. In definite integration, you don't get that constant. You don't get that constant. All right, so that's all about this section. We are going to discuss a lot of problems, lot of such problems as we go through other sections. I think this is enough for this section because the materials here uh, um, are done mostly in other sections too. So that's it. I'll start the next section in another video. Thank you very much.